Okay, counting principles. The first question says, a soccer team has 3 colored jersey tops and 3 colored shorts. Draw a tree diagram to represent the different outfits they could make. Okay, so let's go shorts. They could wear red shorts, white, or black. Okay, then tops, they could wear red, white, or black. So how many different ways could I have this team wear something for their soccer game? How many different ways are there? So this person is wearing, like if I picked this for example, so if I picked that, they're wearing white shorts and they're wearing a black top. That's just one option, right? So how many options are there total? How many different ways could we put these uniforms on? 9 ways, yeah. Okay, we could go red shorts, red top. We could put red shorts on with a white top, right? We could put red shorts on with a black top. Then we could do that. So where does that come from? You could also think of it as 3 shorts times 3 tops. So this is basically a fundamental counting principle. If there's A ways to do one thing and B to do the other, the total would be A times B. So that's what we just did. 3 shorts, 3 tops. So 3 times 3, there was 9 ways we could wear them. Okay, so that's kind of the understanding of that. Okay, you have a luggage set with a lock on it, and it's got a 3-digit code. Each wheel rotates 0 through 9. How many codes are possible? So this is what it looks like. There's 3 boxes, and you have to pick a digit. How many different digits could I pick in my first box on my code? How many different digits are there total? 10. I could have put a 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There was 10 options for me. How many options do you have in the second box? Also 10. How many different options do you have on the third box? Also 10. So you're going to times it. Anybody know what that would make without their calculator? That'll make 1,000 different codes. Question B. So that was A. Suppose now that each digit could only be used once. So you can't use a 4 and then another 4. You can't repeat something. Okay, so in that case, how many options do I have when I pick something in my first box? 10. This is different. How many options do I have on my second part of the code? I now only have 9 options, because whatever I used in the first one, I don't have that anymore, and then 8. So now there's only 720 different codes that are possible. Okay, how many possible ways? We got to get either a black face card or an ace. Okay, do you know your deck of cards? Might even. Okay, don't have one. Alright, do we know our deck of cards? How many black face cards are there in the deck? There's 6 black face cards. Yep, you have king, spades, and clubs. Right? You have a queen. That would be spades and clubs. You don't have to write this down. I'm just showing you. And then you have the jack, and you have spades and clubs. So there's 6 of those. How many aces do you have? How many aces are in a deck? 4 aces. So there's 10 possibilities. Out of how many cards in the whole deck? Do you guys know that number? How many total cards are in a deck? No one plays cards? 52. It's 52 cards. We're going to have to play cards. Apparently you guys don't know your cards. Next, this time you're either getting a red card or a 10. How many red cards are in a deck? How many red cards are in the deck? Well, we just said that there's 52 cards in the deck. What do you know about the ratio of red cards and black cards? Should be half, right? Half the cards are red and half the cards are black. So that would make what? Half of that. 26. How many 10s do you have in the deck? You have 4. But what happened here? How many red cards, how many 10s? Do you understand that I had an overlap? Because what did I do? This one would have included the 10 of hearts and the 10 of diamonds. And so did this one. So I counted the 10 of hearts and the diamonds in this and this. So I can't repeat counting them. So I'm going to subtract 2. Does that make sense? Because I counted it twice. So if I took out all the red cards and then the 10s, I'd actually only have 2 more 10s to take. So that would be 28. There's 28 possibilities out of the 52 cards. Okay, so I gave you that example that this would be they're completely independent, and then this is that there's overlap happening. Okay.